Welcome to the Logic and Quantitative Reasoning Podcast. I'm your host, Dr. Russell Hamadi. I'm an associate professor of philosophy at Houston Baptist University and one of the designers of this course. Wherever you are, if you're driving or doing dishes or laundry, or unwinding after a long day at work, I hope you're having a great day. If you've taken my advice from last week about practicing every day, you're probably listening to this podcast early on in the fourth week. For this week, since we'll be doing proofs, I want to consider for a minute the idea of generating new premises. And the way I want to do that is by thinking about puzzles, two puzzles specifically, the crossword and its numerical cousin, Sudoku. What I want to do is juxtapose the crossword and the word search. So I have a little bit of dyslexia, and so word search puzzles that I had to do in grade school drove me absolutely insane. Like the letters just kind of swam around in front of my eyes, and I basically had to brute force them. I would look at each letter. So let's say I had a big word search grid and I'm looking for the word hypotenuse. So I'll look for all the H's and I would go down each line looking for an H. And when I'd find an H, I would look around, look at the letters all the way around H. Are any of them Y's? No? Keep going. If there is one that's a Y, look in that direction. And I would have to do that for every single word. Because here's something that's interesting about word search puzzles. Finding one word does not then make it easier to find the other words. Knowing one thing in the word search puzzle doesn't help you know anything else. And so these puzzles were, for me, just horrible. The days that we had as our homework, I know the teacher meant it to be something fun, like we're going to do a word search puzzle. My heart just dropped inside, like anything but that. Anyway, I made it through grade school, but if I had to do more word search puzzles, I think I would have, could have just gone crazy. Now, crosswords are different. So with a crossword, you've got a bunch of blank spaces, you've got clues, but those words intersect each other. So if you're able to put in one word in the crossword, there will be other words that then are helped out. So if you figure out 12 across and you fill in hypotenuse, then one of those letters, often many of those letters, will intersect with other words on there, and it will narrow down your choices. So that by the time you get to the end of the crossword puzzle, you might have 2 or 3 words of which you already know several of the letters. In fact, you might only need to come up with 2 or 3 letters to finish filling out that word. So a crossword is neat. A crossword has a cumulative effect. You start with the clues that seem the most obvious to you. When you're looking through those clues, some of them you'll just know right away. And so if you fill in those first, then it will narrow down your choices, and you just keep working at it that way until you get to the words that you're not really sure at all what it means, but now you know it starts with a G. And then, okay, well that narrows it down a little bit and you're able to find things that you need. Now, the crossword, as cumulative as it is still not as cumulative as the Sudoku. Now, I don't know how many of you listening to this enjoy doing Sudokus. My family loves them. My dad does them. He'll buy the Sudoku books and skip to the end to do the very hard stuff. He and my mom will do them together as a team. That's one of the things they like to do on road trips, to bust out the Sudoku and see how many puzzles they can solve. I myself enjoy doing it on occasion, although I like the easy ones. My work is pretty mentally difficult, and so I don't need a challenge. I need some way to just unwind a little bit. But you can make fun of me later for only doing the easy Sudokus. But with a Sudoku puzzle, every number you fill in is helpful. Every time you figure out that, this is a 7, that not only helps that box of 9 numbers, but also helps the entire row and the entire column. And that there will often be a case when you'll be working with a Sudoku puzzle where you're just waiting on one or two numbers. That once one or two numbers get filled in, then the rest of it just falls into place. Now this one goes here. I was always wondering if this was a 9 or a 3, but since 3 is taken, now it's a 9, and you can just move on. And that experience of cumulatively adding information into the puzzle until it's all solved is, I think, a really wonderful one. I think it's very satisfying to be able to do this. Well, doing these logic problems is often the same way, that you're creating new premises, and then when you create those new premises, they fit into the puzzle and they help solve other parts of it. Maybe other parts that are geographically distant from the number that you put in. So in other words, like let's say you're working on a logic proof, you've got 4 premises there, and you're creating some new premises using the rules, the famous form rules, or some of the replacement rules that we'll get into next week. And then while you're doing that, you notice that, this allows you to unlock some part way back in the first 1 or 2 premises that was just sitting there waiting for you to get the piece that unlocked it. In the same way that when you're working on a Sudoku, some box of 9 might be waiting on something, right? And then writing in a 6 over here, all the way on the other side of the puzzle, unlocks the values that you needed for that other square of 9. Now this comparison to Sudoku, I think, is also useful in another way. Once you've created a new premise, that premise it's just as true as all the other premises there, even your starting premises. It's just as true as those. The same way with Sudoku. Once you've put down a 4, that 4 is just as good as the 3 that was pre-printed right next to it. And all of those premises can continue to be used. They never get worn out. You never have to go back and refresh them. It's like, well, we've used this premise 6 times. We don't need to use it it can't be used anymore. It's like, no, all the premises are always available all the time. They're all just as true as any of the other ones. Even the new ones that you create are just as true as the ones before. And that you can work your way towards reaching the conclusion through creating these new premises. All right, let's take a little break, and then I'll come back with some tips on how do you decide which new premise to make. All right, welcome back. Let's think here. How do you know which new premise to make? Now, this is an area that's different from, say, Sudoku or a crossword, right? With a crossword, you know which new thing to write in. That's the one that fulfills that clue and that fits into the number of letters that you have. Or with Sudoku, you write in the next number because it's the only number that'll fit there. And so you have some, it's constrained for you as far as how do you know which number to write in next. When it comes to these logic proofs, that's not the case, because there are some operations that you can always do no matter what. So for example, the rule of addition, where if you take any proposition and you can always add an or to it and then anything you want. So for example, let's say there's something that I already know is true. So one of the things that's true is that on the desk that I'm sitting at, there is a blue teddy bear sitting there. My youngest daughter put it there to keep me company sometimes when I'm sitting in here working alone. So there is a blue teddy bear on my desk. Well, I can put that statement, there is a blue teddy bear on my desk, put an or next to it, and then put anything that I want. Anything. It's limited only by the power of my imagination. Because if I already know, remember with an or statement, only one side of it has to be true. And if I already know something that's true, then the other side could be true or false. It doesn't matter. The statement as a whole is still true. So if I said, well, there's a blue teddy bear on my desk, or I am an alien, like, well, that's true. That statement as a whole is true. You can or and then put anything you want into it, this rule of addition. Well, the rule of addition is always valid. You can do it at any time. Other things that you can do at any time, you can use conjunction to take any two statements that are already true and put them together with an and in the middle, and that's always correct. So how do you know, since there's certain operations you can do that are always correct, how do you know which ones to do? Well, there's a few principles to keep in mind. One, practice. You will start to notice which things will be the most helpful, but that only comes with experience. Think of the difference between an auto mechanic with years of experience, listening to the car run, and then say, something, I think it's this, and you can make a really good guess just by feel. And if you ask them, like, well, why did you examine that first? I mean, maybe they could tell you, but probably they just had a really good feeling, and that feeling is brought on by just lots of experience, lots of practice, seeing lots of cars and hearing that sound lots of times. So if you're wondering, like, well, how will I know what thing to do? One way is just to practice it enough, and I do sound kind of like a broken record here, but practice it enough to where it just feels natural, and you're like, oh yeah, this needs to happen next. You're like, well, why? It's like, it does, trust me. And then you do it, and it's probably right. So that's one. Well, what about before you have all that experience? What are some other things? One that I think is often underrated is working backwards. And we've had some experience. Everyone's had this experience working with these maze puzzles, where it's so much easier if you work from the end point backwards to the starting point. A lot of the dead ends and things they just won't be as problematic if you're working backwards from the end. So if you're strategizing while looking at these proofs, and you say, okay, well, what am I trying to reach? I'm trying to reach this conclusion, right? I'm not trying to do just any operation at all, and hopefully at some point the operation magically produces the conclusion. I'm trying to reach the conclusion. I'm trying to get there. So what kind of operation could be used in order to create this conclusion in the first place? Is the conclusion's primary operator an and? Right. So okay, well, probably what I'm going to need to do is find each halves of that and independently, and then my last step will be using conjunction to bring them together. Or you look at the conclusion and notice that it's an or statement. Like, oh, that's interesting. Maybe I find one half of that or statement and then use addition to get the other half, just out of thin air. Maybe this is a result of a dilemma, right? A constructive dilemma, in which case I'm going to be looking for another or statement and then a couple conditional statements to join those together. Maybe that's what I should be on the hunt for. And then from there, you start working your way backwards, and you'll probably meet in the middle somewhere. Like your exploratory operations you'll do at the beginning, and then a little bit of strategy about where the end, working backwards from the end, and you'll probably meet in the middle, and then you'll just have the proof. You just then need to write it out. A couple other things, little tips that might be useful. Getting things out of a parenthesis is usually a good idea. So if you have something tucked away inside a parenthesis, maybe with a not in front of it, or maybe as the consequent to a conditional, getting it out of the parenthesis means that you can then start using the components, and that's pretty useful. Another thing that you could do is just usually a good thing is making smaller chunks, getting a smaller chunk of a premise by itself. Yeah, that's usually a good thing too. So that means that things like modus ponens or modus tollens or a disjunctive syllogism are almost always good moves. Not always. I mean, not every single time, but usually having something by itself, a smaller chunk, will often unlock other pieces elsewhere. So that's a good idea. So when you can, MP, MT, or DS, go ahead and do that. If there's a way for you to get something out of a parenthesis, go for it. And then, like I said, work backwards. And to repeat my broken record, practice. Practice. All right, well, I think that's all for this week. I'll see you all next week. Good luck with the homework. I have a feeling that this week there'll be a lot of activity in the homework help forum. So good luck. See you next week.